All right, so each day when we start out, on the screen we'll see that night's homework and the day that we are. So you'll always be able to look at the calendar that is on the front of the unit packet. Remember, if you don't have your unit packet yet, which if you're watching this video, it probably means you're remote today, the unit packet is listed as a PDF. If you go to the course materials and resources and click on Unit 1, you'll see Unit 1 packet, and it is right in there. So page 43 is what you want to be doing for homework tonight. Remember, homework always needs to be uploaded by 5 a.m. on the day it's due. So for this assignment, it would need to be uploaded by 5 a.m. On Tuesday morning. Okay, the reason being is I'll usually check them right when I get up, and I can't walk around and check homework this year, even for people that are in class, because we got to stay 6 feet apart. So each day you'll have at the top what the homework is. If you like to keep a planner with your list of assignments, that'd be a good thing to write down right at the start of class each day. The other thing we'll also do most days is have a warm-up. So if you weren't in class today, but you're going to be in class on Monday, you'll be getting a warm-up sheet to help you organize and put those. And there'll be a bunch of boxes on it, and you just put it in for that day. So this would go in a Monday box. Since you're not in class today, just put it on a separate sheet of paper, and you'll get your warm-up sheet soon. So we want to know what are the next 3 terms in this sequence. So first off, what is a sequence? The first half of this unit is looking at different sequences. And a sequence is just a list of numbers that follow some type of pattern. So we want to look at this first one and see if we can determine what is the pattern that is going on. And hopefully you're able to recognize that the pattern is that we are adding 5 each time. So the next 3 terms in our sequence should be 28, 33, and then 38. In the second one, our pattern is we're multiplying by 2 each time. So if we multiply by 2, we should get 96, 192, and then 384. So again, the first half of this unit, we will be looking at different types of sequences. So lists of numbers that have some type of pattern. Now next, what we would normally do is we would go over the previous homework that you turned in. So even though you're taking a picture of it and submitting it by 5 a.m., make sure if you're in class that you're still bringing that copy of the homework with you, so you have it to make corrections on and reference. And if you are remote, make sure when you sign on to the Google Meet that you've got that homework available so you can also make your corrections and ask questions as we go through it. So over the weekend we didn't have any homework. So we're just going to get started on packet page 1. For those of you that are remote today and don't have your packet yet, you can just write down the pertinent things on a separate sheet of paper. Basically anything I write in, then you can transfer that over when you get your packet if you haven't gotten it yet. So, formulas to describe patterns. So our notation when we're working with sequences is often a letter and then a subscript. The most common letter you see is A, but it could be other things. You could do J, you could do T, you could do B, really could do any letter, and then a subscript. Subscript means it's down below. So the A with the 1 as a subscript means the first term, A with 2 as a subscript means the second term, and so on. And then whatever number's in that spot is your value of that term. So our value of A1, the value of the first term is 5. The value of A2, the second term, is 8. A3 is 11, and so on. So we want to try and figure out how could we fill in that blank. And the answer is there's two ways we could do it. We could do it as a recursive formula, which means that we somehow relate each term to the one that came before it. Or we could do an explicit formula, which allows you to jump to whatever term you are looking for. So we're going to look at both of those options. So moving down to the bottom of page 1, still with the same thing, let's look at a recursive formula. A recursive formula always has two parts. You first always identify what the first term is. So here we have a1 equals 5. And then next, we're going to always do an equals, and a recursive formula always has an a sub n minus 1. Well, if a sub n, sub just means it's the subscript, so a sub n means the term we're working with, so a with an n minus 1 in the subscript means the previous term. So that's all you need to know, is that a n minus 1, that is just the previous term. So it's a tricky notation, but it just means previous term. So to that an minus 1, we just need to tell what the pattern is happening. Are we multiplying by something, dividing by something, adding, subtracting? Well, hopefully you're able to recognize that the pattern here is that we're adding 3 each time. So what we would do is at the end, we would just put a plus 3. So what this recursive formula tells us is we should start with the number 5, and each time just add 3 to get the next term, which seems logical based on the sequence that we're looking at. Now the explicit formula is on your reference sheet. Now this reference sheet is under the resources page, not in a unit folder, but just the main resources page. Now, if you've been in class so far, I've given you a solid copy of this, a hard copy of this. If you haven't been in person in class yet, then you can just reference it as a digital copy on Schoology. So eventually we're going to talk about why we will use this formula, but we're going to use this an equals a1 plus n minus 1 times d. And the reason we use that is because it's a pattern that is adding over and over again. And we'll spend a whole day with that tomorrow. Oops, an equals a1. And then at the end, the formula sheet just has the d there. I like to make sure it's in parentheses so that it's clear that it's multiplying. Because if you just put d, it could potentially look like you're subtracting if you put a negative number in for d. And let's see where that formula comes from. Well, this has 5 as the first term. 8 is really 5 plus 3. 11 is really 5 plus 3 plus 3. Let's see if we kept going, like 14 and 17. 14 is 5 plus 3 plus 3 plus another 3. 17 is 5 plus 3 plus 3 plus 3 plus 3. Because each time we're just adding another 3. So notice they all had the 5. That's where the a1 comes into play. D is what we are adding on each time. Well, this had 3 times 1. This one had 3 times 0. This one had a 3 times 2. This one has 3 times 3. And this one has 3 times 4. Well, notice the first term had 0. The second term had a 1 3. The third term had 2 3s. The fourth term had 3 3s. The fifth term had 4 3s. So there's always n minus 1 3s. So if we're looking at the sixth term, we would have 5 times 3 going there. That's where that is coming from. And again, we'll work with that formula a bit more tomorrow. So our main focus today is identifying recursive and explicit formulas. A recursive formula will always have an a sub n minus 1 in it. And remember that a sub n minus 1 just means the previous term. An explicit formula will just have an n in it, where we will sub in the specific term we want to find. So hopefully this first choice here, and this is at the top of page 2, Hopefully this first choice you can identify. This is going to be a recursive formula because it's got the a sub n minus 1. They tell us a1, which they have to do in a recursive formula, and we're going to find the first 4 terms. So next we're going to do a2, and we're just going to follow this formula. The formula tells us to do 2 times the previous term minus 3. Well, if we're doing a2, the previous term would be a1, so we just fill in that 4. 2 times 4 is 8, minus 3 is just 5. So now let's try a3. Again, our formula here is 2 times the previous term minus 3. We'll just take your previous term and fill it in. So we're doing 2 times 5 minus 3. Well, that would be 10 minus 3, which is 7. And they want us to go up to the 4th term. So we'll have a4. We'll follow that same pattern of 2 times the previous term minus 3. Take that previous term and fill it in. 2 times 7 is 14. 14 minus 3 is 11. So our first 4 terms, we got 4, 5, 7, 11. So that's how you would do any recursive formula. You're just filling in the previous term, and all that will change is what the a1 is and what that formula is that you're subbing into. Now in an explicit formula, you just directly sub in for n the term you're finding. So if we want a1, we're going to take that 1/2 and just sub in 1 for n. Well, anything to the first is itself. For a2, we would sub 2 in for n, and this squares both of them. 1 squared is 1, 2 squared is 4, so we get 1/4. The third, we would sub 3 in for n. We'll raise them each to the third. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And lastly, to the 4th, we just sub in 4 for n. So 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. So our first 4 terms are 1/2, 1/4, 1/8, and 1/16. So what we'll talk about soon is, say we wanted to find like the 40th term. If you use a recursive formula, you have to find all 39 that come before it. But if you use an explicit formula, you could just sub in 40 and you automatically get the 40th term. So that's why explicit formulas are more helpful when you want to find something way down the line, as opposed to the recursive is more helpful if you want to find just one of the first couple. So those were 2 different sequences that we looked at. And by different sequences, notice it went 4, 5, 7, 11, 1/2, 1/4, 1/8, 1/16. Totally different numbers. But what we're going to do now is see if for the same sequence you can write both a recursive and an explicit. So this is on the bottom of page 2. So we'll start out with a recursive. A recursive formula, you always tell what the first term is. And then you always say an equals and have an minus 1. And I always like to leave a little space in front just because we could end up multiplying by something. Well, now see what your pattern is. 1 to 3, 3 to 9, 9 to 27. What's happening each time to go from one to the next? Hopefully you're recognizing that we multiply by 3 each time. So we can need to do times 3, and we can do it one of 2 ways. You can either put times 3 on the end like that, or if you want, you can put the 3 out in front and do 3 and then times it. Either one is perfectly fine, just make sure it's clear that it's got the times. So now for our explicit. For an explicit formula, we'll have an equals. And what we will talk a lot about in 2 days in our video on Wednesday is that if you're multiplying, that's what we'll eventually call a geometric sequence. So looking ahead, notice on our reference sheet we have a geometric sequence formula. The A1 represents the first term, and the R represents what you are multiplying by. So I'm going to take that geometric sequence formula, again the fourth one down on the right, I'm going to write it over here for us. And what I like to do is put that R in parentheses, even though it's not on the reference sheet. This is because if R happens to be negative or a fraction, you'd have to put it in parentheses. And what we want to fill in to get our formula is just the first term, which in this case was 1, and fill in your R, which is what you're multiplying by, which in this case is 3. And that is your explicit formula. Now, if we had been adding something over and over again, we would have to use the arithmetic sequence formula, the third one down there. And we'll see that in the next one. All right, second one, number 2, we want to do a recursive formula first. Always tell what A1 is. And then you'll always have AN equals AN minus 1. And then see what is the pattern that is happening when you go from one term to the next. Hopefully you recognize you're subtracting 4 each time, so we can just do minus 4 on the end. Now both of those things together make up the recursive formula. If you're missing one of them, that's not a complete recursive formula. Now our explicit formula, remember explicit formulas come right off our reference sheet. Since we're subtracting 4 each time, we would use a arithmetic. So on our reference sheet, it's the third one down on the right. We have AN equals A1 plus N minus 1 times D. And I'm going to copy that over to the smartboard. But one thing I'm going to write differently is get in the habit of writing that D in parentheses. Even though it's not shown that way. And also make sure you have the plus after the A1. Over the years, I've noticed people forget to put that plus in all the time for some reason. So just like in the previous one, where AN and N are going to stay in the formula, we just have to fill in for A1 and D. So in this case, our first term was the 9 plus N minus 1, and we were subtracting 4 each time. So we got to make sure we put in D as negative 4. Now, putting that D in parentheses, if we hadn't put it in parentheses, it would look like it was a subtracting of 4 on the end, and in the formula you need to multiply by whatever the D value is at the end. For the sequences above, which formula would be more convenient for finding the 150th term? And this was something I just mentioned on the previous slide, but the explicit is better. Because that can directly find you the 150th term. If you wanted to use recursive, you would have to find all 149 terms that come before it. Okay, so for each of these, we're going to write the recursive formula and then the next 3 terms. So we know we have to write our first term. A1 is equal to 2. And then we always do AN equals and do AN minus 1. And then just tell what the pattern is. Well, here we're adding 4 each time, so we should have plus 4 on the end. So then our next 3 terms, we should have 18, 22, and 26. In the second one, first term is 10. Always have AN, and then AN minus 1. What's our pattern that's happening each time? Well, each time we're subtracting 5. So just throw a minus 5 on the end, and that's our recursive formula. Third one, tell what our first term is. A1 equals 1. We'll have AN equals A with N minus 1 as the subscript. Again, that just means previous term. We need to see what's the pattern. So we have 1/3, 1/9, 1/27th. There's actually two ways that you could represent this. You could either say that we're multiplying by 1/3, or you could say we're dividing by 3. Because if you remember back in middle school, keep, change, flip is what you do when you divide. So if we change the divide by to multiplication and then flip 3 to become 1/3, those are the same. So you could either do 1/3 times the an minus 1, or this would be correct as well if you did an minus 1 all over 3. Both of those would be correct answers. On the Regents, recursive ones are really popular and they usually show up as multiple choice. So you would just need to recognize which one of those two, whichever they showed you. And now we're going to try writing an explicit formula for each of these. First, we want to see what the pattern is. This one, we are adding 1 each time. Now we're going to do a whole day with ones we're adding and subtracting tomorrow, but that is what is called an arithmetic sequence. If we go back to the reference sheet, that's our an equals a1 plus n minus 1 times d, which is the third one down. So again, that's only used when you're adding or subtracting. If you're multiplying, we would use the geometric one. So our formula, we would have an equals our first term of 3 plus n minus 1 times whatever we are adding on each time. Now, if you're subtracting, you're really adding a negative, but we were adding positive 1 there. In the second one, -2, 3, 8, 13, we're adding 5 each time. So our explicit formula, we would have -2 plus n minus 1 times 5, because that's what we're changing by each time. All right, so in the last one here, we're clearly not adding by the same each time, because 2 to 3 you're adding 1, and 3 to 4.5 is not adding 1. So we want to think multiplying. What are we multiplying by each time to go from one to the next? Well, if it's not obvious, the opposite of multiplication is division. So what you do is you do the second divided by the first, and that'll give us our R value, what's called the common ratio. And that is what you multiply by each time. So for us, we would do 3 divided by 2. And you can either leave it as 3 divided by 2, or that's the same as saying 1.5. So because we are multiplying, we would want to use our geometric sequence formula, which is the fourth one down there. A1 times R to the n minus 1. So I'll write that formula here. Oops, AN equals A1 times R to the n minus 1. So we'd fill in our A1, which is 2. Fill in your R. You can either do 3/2 or 1.5 and raise to the n minus 1. So you'll be working with explicit and recursive formulas on your homework. Again, that's on page 43 of your packet. And remember, you need to upload that right on Schoology. Take a picture and upload it right up there. And then have that with you either when you log on to Google Meet tomorrow, or if you are in class, so you can ask questions and check your answers.